Before anything can be made, it first has to be designed. This is where I can work on those designs, and I can conceive of a new product, component, or come up with a change that I want to make. First, it starts with hand sketches, but then quickly it'll move onto a computer, and I will utilize different software programs to help me draw components in 2 dimensions and 3 dimensions, and that software is called CAD. It's computer aided drafting or computer aided design. It's really gotten quite complex now. It's a lot more than just drafting. There is a lot that we can do on a computer in order to test and actually help with the design of a new component. We can choose things such as materials and tempers. We can check the stress of a component based on the motion. We can do all kinds of things with software. So on here, I have a design, and that simply means I have a drawing. We need 2-dimensional drawings in order to manufacture a part. 2-dimensional drawings will have not only the dimensions that are essential for that component, but it will also have the tolerances for each feature, so that when we machine them, we actually make sure that a hole is a certain size. If we have a 3mm hole and we use a 3mm drill, we're not going to have a 3mm hole once we measure it out. It will be slightly more or slightly less. And as that drill wears out, the size of the drill shrinks. So we have to determine at what point that hole size no longer works. Is it 2.99 millimeters? 2.98 millimeters? Or, if the hole is too large, at what point it will not function the way we need it to. 3D is necessary to actually see the components and how they interact with other components. And then it's also necessary if we want to utilize something such as CAM, which is computer aided manufacturing. Now with a CAM software, we can actually take a 3D part and program a machine with tool movements and all sorts of other things. Tool changes, tool movements, any special way of cutting a part, using coolant, no coolant. These are all simply codes that we need to present to the machine, and it will read those codes and do what we want it to do. CAM software helps us write that code. When we input our 3D part file into the software, and we know what tools we have, what machine we're intending to make this part with, and how we want to process it. It's a little bit of a shortcut to writing a complex program for a CNC machine, almost like a video game, so that I don't have to test with real world tools and materials until we're further along. And I know that I'm not going to damage or break something, because the stakes are very high with these machines. They're very powerful, and if we crash this machine, it can be very costly, and it can take a long time to fix, because this is precision equipment, and in order to make precise components, our equipment has to be operating almost perfectly, along with very rigid guidelines for setting them up and how we actually operate the machine. This is an example of a part. It's actually 3 parts that have been set up here in CAD. And the reason there are 3 parts here is because I can take these 3 3-dimensional parts in their current location and cut them out of one piece of metal. And that's because I've designed the process that way. I could also cut each individual piece on its own, but I have 3 in one file so that I can transfer this to my CAM software, write the toolpath as one program to cut 3 parts out of one piece of material by hitting the button on the machine once. This is an example of a watch case. Right here, the 3D part has been input into CAM software. I've written an entire program, and now I can actually watch the machining of that part take place. And this lets me know that there are no major flaws where maybe I've input something incorrectly so that my machine will crash and damage itself. This saves me time and money. As a watchmaker, we always go the extra step to add decoration. Things like Geneva stripes, polished surfaces, brushed surfaces, vertical, horizontal, circular brushing. All of these things are finishes, and those will be applied using a number of different machines. The machines sitting behind me are the ones I use for finishing. I have different polishing motors with different brushes, with different wheels, and I use different polishing compounds. I also have components that are polished by hand with special tools that allow me to hold things perfectly perpendicular to a polishing surface, or there's even plating of certain components, electroplating. All of this finishing takes place in this little work pod in the back corner of my workshop, utilizing certain machines for plating, certain other machines for polishing, sandblasting, media blasting, different polishing wheels with different grits and abrasives, and also laser marking. Laser marking allows me to cut or mark on metal in a way that I couldn't do with an engraving tool, because a laser does not actually have any dimension. So using a laser for cutting or engraving allows me to have sharp internal corners. If I was to use a 3-dimensional engraving tool, I have to leave some space for the tool. So there will be a radius on an internal corner, and it cannot be a true corner. With the laser, that's possible. So utilizing all these different tools, different workbench setups, everything that I have at my fingertips in this workshop, I'm able to finish almost all the parts of a mechanical watch and then bring them over for cleaning and assembly. In my workshop, this is a very small crew. I have my hand in pretty much every part of the making of a Weiss watch, including the final step. And the final step is when that watch is paired with a strap, it's packed up into its box, and then shipped off. So I have a packing and shipping station here that allows me to finish those watches by taking the order, pairing it with a watch, making sure the right strap goes on the watch, shipping it out, signing the certificate of authenticity, and even handing it off to the mailman. Because we're a small team over here, I've laid out the workshop in such a way where everything's really close. I'm only 10 feet away from where parts are being machined. And that's where the finished watch will have its strap added and be shipped out to its new home. In larger workshops, that might be a completely different warehouse where a finished watch goes and then waits to be sold. Some watches made in Switzerland may even be shipped to the US without straps, and the straps will be added here in the US. The packaging will then be added, and the COA cards, or certificate of authenticity, will then be dated and stamped at the time of sale. There are a lot of logistical reasons why a watchmaker will set up their final step of getting that watch to the customer in a different way. And for me, this works. In fact, it's the only way I can see it working. And I think I really enjoy being able to have my hands on that watch and be the last person that touched that timepiece before it goes off to its new home. Something I find extremely interesting about watchmaking is the individual watchmaker and how they set up their workshop to make the watches that they love to make. That's a very individual thing for each watchmaker. It's almost like an extension of their own persona. So hopefully in the future, we'll be able to walk through some other workshops and see how other watchmakers have set up their workshops, how that might be different from my workshop here, and then we can even look at the watches that are produced and see how they differ. Because it is art, and every watchmaker is an artist, and every watchmaker's workshop is an art studio.